Yes. Sorry. Good morning, students. Sorry, there was some problem with the system, all those things. Okay, now it's working. Fine. In today's class, I hope now it's okay. Okay, I think. Yes. Fine. Good morning, students. I'm late by 20 minutes. Okay, due to some issues with the camera and all those things. Anyway, let me start. Today's concept is refraction. Visible, right? Today, let us discuss about a new concept called refraction. Actually, it's not a new concept. You have already studied in your high schools, all those things, all these things you have already studied. This concept is called refraction. In today's class, let us try to understand laws of refraction, some points about refractive index, a new constant, and what is the meaning of absolute refractive index? Ri stands for absolute, refractive index. Ri stands for what? Refractive index. And what is the meaning of angle of deviation? What do you mean by angle of deviation? Some natural consequences related to refraction. In these natural consequences, we have to study. First one is lateral shift, and second one is normal shift. And if possible, TIR means total internal reflection. Sampurna Antarika Pratifalana. We have to study. Now, first question is, what do you mean by refraction? We have discussed in first or second class, right? Refraction is a light phenomenon. It's a phenomenon where a ray of light from one medium is incident oblique incidence. Oblique means obliquely on the interface on the refracting surface separating two medium 1, medium 2, two media. Then we observe there is change in direction of light, change in direction of propagation of light. This phenomenon where ray of light changes its path at its interface separating two media is called refraction. ಬೆಳಕು ಒಂದು ಮಾಧ್ಯಮದಿಂದ ಮತ್ತೊಂದು ಮಾಧ್ಯಮಕ್ಕೆ ಓರೆಯಾಗಿ ಪ್ರವೇಶಿಸುವಾಗ obliquely we observe there is a change in path. ಅದು ತನ್ನ ಪಥವನ್ನು ಬದಲಾಯಿಸುತ್ತದೆ. ಪಥ means path. ಪಥವನ್ನು ಬದಲಾಯಿಸುತ್ತದೆ. This phenomenon is called refraction. Here in this picture, see carefully. Let us consider beam of light. I am using the beam, not ray, beam of light. When it is incident on refracting surface, this is refracting surface. Refracting surface. On some interface separating these two medium, refracting surface, we observe part of light is reflected. ಯಾವಾಗ ಒಂದು ಬೆಳಕಿನ ಕಿರಣ ಫ್ಯೂಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಆಗಿದೆಯೋ a part of light is reflected and part of light is transmitted. Part of light is entered in second medium. Here we have two medium 1 and medium 2. What we have considered here? We have considered a ray. This ray is called as usual incident ray. incident ray. This ray is called refracted ray. This ray is called refracted ray. And this ray is called, reflected ray. Here we have two medium. We have considered the first medium as a rarer medium. Rarer medium. Rarer medium means Virala Madhyama. Second medium is called denser medium. Denser medium. It is a optically denser medium. Optically denser medium. Optical denser medium. Not your usual mass density. It's denser due to optical density. ಇದು ಹೇಗೆ denser ಆಗಿದೆ? It is due to optical density. What is the difference between mass density and optical density? Mass density, density is given by mass by volume. Correct? Whereas this optical denser medium is calculated by speed of light, velocity of light. It's calculated by ratio of velocity of light in a given two media. Remember, optical density is definitely different from what you know mass density. Okay? There is difference between mass density and optical density. Now, this is rarer medium. Say air or vacuum. We usually consider it as a rarer medium. Okay, it's a rarer medium. Air, a ray of light is traveling from air to water. Here, if it is water, then water is more dense optically than air. So, the water is denser medium. Hope you understand. Water is denser medium. Air is rarer medium. If you consider water and glass, now your water will be rarer medium. It's optically rarer. Your glass will be denser medium. It all depends on pair of media you have considered. ಯಾವ ಎರಡು ಮಾಧ್ಯಮಗಳನ್ನು ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀರಿ ಅದರ ಮೇಲೆ ಇದು ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಓಕೆ, incident ray, refracted ray, reflected ray, and a normal. Medium 1 which is rarer, medium 2 which is denser. It is optically denser medium. Okay, now for time being, let me forget this. What? For time being, let us forget what? There is some reflection, all those things. Let us consider only refraction. A scientist called Snell experimentally studied this refraction, and he gave two laws of refraction. Here we have laws of refraction. For first point. First law is similar that you have studied in case of reflection. What? According to first law, incident ray, refracted ray, and normal drawn at a point of incidence, all these lie in the same plane. Let me repeat. First law: incident ray, refracted ray, and normal drawn at a point of incidence all lie in same plane. As I have studied earlier in case of reflection also, there was such law, right? There is one such law. What about second law? Second law is well known as Snell's law. Second law, most of the time, second law is called Snell's law. Snell's law of refraction is Snell's law or second law. Second law of refraction. This is very important. According to second law, the sine of angle of incidence. What? Sine is the angle. Sine of angle of incidence. Angle of incidence in your term. The ratio of, I forgot to mention the ratio. The ratio of sine of angle of incidence to sine of angle of refraction is a constant for a given pair of media. Is constant for given pair of media. Pair of media, air water, air glass, water glass, whatever it may be. Given pair of media. And this constant is called refractive index. This constant is called refractive index. N or mu also. Okay, we will consider only N. For given pair of media, for given pair of color or wavelength. Whatever. Let me repeat second law. According to second law, the ratio of sine of angle of incidence to sine of angle of refraction is a constant for given pair of media. For given pair of wavelength. This is called Snell's law. Here, this is normal. N dash is a normal. Angle PQN is called angle of incidence. PQN is called angle of incidence. Whereas angle N dash QR is called angle of refraction. Angle of refraction. This is called Snell's law. Snell's law holds good for what? Oblique incidence. What is oblique incidence? Making a certain angle with the normal. It is not valid for all situations. For example, see. Visible. Let us consider a refracting surface interface separating two media, medium 1, medium 2. Now, let us consider a ray of light along the normal. Then what about refraction? What about Snell's law? Hope you understand. Imagine a ray of light is moving in the direction of normal. ಬೆಳಕಿನ ಕಿರಣ ನಾರ್ಮಲ್ ಗುಂಟ ಚಲಿಸ್ತಾ ಇದೆ. Then your light will travel in the second medium, maybe denser or rather, without any deviation. One more question, what do you mean by deviation? Let us discuss. ಒಂದು ವೇಳೆ ಬೆಳಕು ನಾರ್ಮಲ್ ಗುಂಡ ಬಂದ್ರೆ ಯಾವುದೇ ಡಿವಿಯೇಷನ್ ಆಗದ ಹಾಗೆ ಸೆಕೆಂಡ್ ಮೀಡಿಯಂ ಎಂಟರ್ ಆಗುತ್ತೆ. And remember, your angle of incidence or angle of refraction always measured with respect to normal. They are measured with respect to normal only. This is the angle of incidence. This is the angle of refraction. When your ray enters the second medium along the normal, then angle of incidence will be 0, of course. There is no angle. It is along the normal. So automatically the angle is 0. We have to measure all the angles with respect to normal only. There is no question of angle. I is 0. What about R? Is also 0. What about Snell's law? Sin I by sin r is equal to, I have written n alpha. Let us discuss. Is it exactly n or not? Whatever. Now, sin 0, I is 0. So sin 0 is equal. I is 0, sin 0 divided by sin r is also in 0, 0. Which is equal to 0 by 0. Which we know it is what? Not defined. Not defined. So your Snell's law fails for normal incidence. This is the point I want to tell you. Let me repeat. What point I want to tell you? Very simple. For normal incidence, your Snell's law fails. Snell's law definitely not holds good for normal incidence. Other than normal incidence, your Snell's law is okay. You can apply Snell's law. For normal incidence, Snell's law is not well. It not holds good. Hope you understand. Now, usually we write not simply n. Refractive index of second medium with respect to first medium. N21. N21 means what? N21 means, let me write Ri for refractive index. Refractive index of second medium with respect to first medium. So, this is N1, first medium. Now you can understand that. This is N2. Is it? Okay, let's write somewhere here. This is N1, first medium. Then this is N2. Now, N21 represents refractive index of second medium with respect to first medium. Let me repeat. Refractive index of second medium with respect to first medium is written as N21. Correct? Okay. Or N21 is equal to, we can write it as N2 by N1. Remember, we can do this. Just remember, but I mean N21 is also equal to N2 by N1. Refractive index of second medium with respect to first medium is written as N2 divided by N1. We can express like this, which is equal to, we know, sin I divided by sin R. Correct? Just cross multiply, what we get? We get N1 sin I is equal to N2 sin R. Very important equation. This equation is called sometimes general form of Snell's equation, Snell's law. It is called general form of Snell's law, where N1 first medium only we have angle of incidence. N2 is second medium where we have angle of diffraction. So, point to be remember, refractive index, first medium, second medium, then denser, rarer, and normal, incident ray, refracted ray. We usually come across in case of diffraction. Now, what is the SI rate of refractive index? Just think. Your refractive index has no unit because it's sin I by sin R. It has no unit. It's just a number. Refractive index is just a number. You are supposed to remember some of the refractive indices. Like refractive index of air or vacuum, by default we take it as 1. Refractive index of air or vacuum, we take it as 1. Refractive index of water is 1.33. While solving problems, you just come across such values. Definitely we come across. Refractive index of glass is 1.5. There is some, as I have given in notes, there are some other values also, print glass, dense glass, all those things. Refractive index of diamond is around 2.4 if I am not wrong. 2.4. Exactly. 2. Okay, whatever. See, these are the values of refractive. It's a pure one. Okay, this is first thing. Second thing, you have to remember. See, N2 1 refractive index of second medium with respect to first is equal to what? N2 by N1. Correct? Is also equal to reciprocal of refractive index of first medium with respect to second medium. Of course, this also correct. This is very what? Refractive index of second medium with respect to first medium is reciprocal of refractive medium of first medium with respect to second medium. Remember, we can do this. No need, just remember this. Okay, just let me eliminate this. Then what we have? We have this equation. Correct? Okay. Now, let's discuss some points about deviation in case of refraction. And why we need? Let us discuss later. What do you mean by deviation? See here. Let us consider interface separating two media, say rarer of refractive index N1, denser of refractive index N2. A ray of light is incident, say PQ, and we have already declared it as a rarer and this as a denser. Then we observe ray of light. Okay, bends towards the normal. This is my point. When ray of light travel from rarer medium to denser medium, it will bend towards the normal. It bends towards the normal. This is R. Or you observe change in path of light. There is change in path of light. In the absence of second medium, say, in the absence of second medium, ಎರಡನೇ medium ಇಲ್ಲದೆ ಹೋಗಿದ್ರೆ, ಎರಡನೇ medium ಇಲ್ಲದೆ ಹೋಗಿದ್ರೆ, this ray would have traveled in this direction. ಈ ray ಏನು ಮಾಡ್ತಿತ್ತು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಆಗ್ತಿತ್ತು. And draw it, right? In the absence of second medium, this will be the path traced by incident ray. ಎರಡನೇ ಮೀಡಿಯಂ ಹಿಂದೆ ಹೋಗಿದ್ರೆ ಇದು ಈ ರೇಖೆ ಚಲಿಸುವ ಏನಾಗಿತ್ತು ಪಾತ್ ಆಗಿದೆ. ಡ್ಯೂ ಟು ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸೆಕೆಂಡ್ ಮೀಡಿಯಂ ವಿ ನೋ ray just changed its path. Ray just changed its path. Then this much amount is deviation produced. What? This is a deviation produced. This is deviation produced. What is deviation then? Very simple. Deviation is defined as it is an angle between incident ray extended and refracted ray. Echo ಆಗ್ತಿರಬಹುದು ಮತ್ತೊಂದು ಸಲ ಇದನ್ನ ಕೇಳಿ. Deviation is defined as it is an angle between incident ray extended. Incident ray extend ಮಾಡಿದ್ರೆ action ಮಾಡ್ತೀರಿ. Imagine in the absence of second medium, ಎರಡನೇ medium ಇಲ್ಲದೆ ಹೋಗಿದ್ರೆ this will be the path of incident ray. But due to presence of second medium, you know this is actual path now taken. So there is some difference between actual path. Actual path ಹೇಗೆ incident ray extended and refracted ray is refracted is called deviation. Is called deviation. In case of this is angle of incidence. In case where ray travel from rarer medium to denser medium, then deviation is given by I minus r. What is I? Angle of incidence. Of course, you can see value of I is more. I ಏನಾಗಿದೆ ದೊಡ್ಡದಾಗಿದೆ. R is less. Depend ಆಗಿದೆ. R is less. Ultimately, deviation will be I minus r. Deviation will be what? I minus r in case of ray traveling from rarer medium to denser. It is not only the case. Ray may travel from denser medium to rarer medium. Then what will happen? Of course, very interesting. Imagine some source of light scattered inside the denser medium. This is denser medium. Now, a ray of light is incident from denser medium, say PQ. Here you observe ray of light of refraction bends towards the normal. Here, definitely it will bend away from the normal. Now, this is the angle of refraction. This is the angle of refraction. This is angle of incidence. Of course, this is angle of incidence in denser medium. This is angle of incidence in denser medium. This is angle of refraction in rarer medium. Please try to understand. This thing we are going to use in one more concept called total internal reflection, where a ray of light, beam of light, is allowed to pass through what? Denser medium to rarer medium. Denser medium to rarer medium. Total internal reflection. Okay, we will discuss it later. Now, for time being, imagine if ray of light is traveling from denser medium to rarer medium, refracted ray bends away from the normal. If incident ray is traveling from rarer medium to denser medium, then it will bend towards the normal. Here, deviation will be, in second case, deviation will be r minus I. Definitely, r will be greater. Definitely, value of r is more. Automatically, d is equal to r minus I. D is equal to r minus I. Hope you understand. Okay. ಈ ಪಾಯಿಂಟ್ ನಾವು ಯಾಕೆ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ವಿ, ಈ ಡಿವಿಯೇಷನ್ ಯಾಕೆ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ವಿ, ಇಮ್ಯಾಜಿನ್. ಓಕೆ, see here. If refractive index of second medium with respect to first medium is greater than 1, then ray bends towards the normal. Bends towards the normal. If refractive index of second medium with respect to first medium is greater than 1, then ray bends towards the normal. One way, refractive index of second medium with respect to first medium normal kade bend ಆದರೆ ray normal bend ಆದರೆ ಏನು ಅರ್ಥ? The ray must have traveled from rarer medium to denser medium. ಇದು ಹೆಂಗೆ ಗೊತ್ತಾಗುತ್ತೆ ನಮಗೆ? ಸಿಂಗಲ್ is incident angle I, this is refractive angle I, sin I by sin R. is equal to N2I. If value of I is greater, then N21 will be greater than 1. Correct? If value of I is greater, I ಜಾಸ್ತಿ ಅಂತಂದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ N21 is greater than 1. N21 ಬೆಲೆ 1 ಕ್ಕಿಂತ ಹೆಚ್ಚಾಗುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಇದಕ್ಕೆ ಹೆಚ್ಚಾದ್ರೆ ray of light is starting from narrow medium to denser medium ಅಂತ one more question ಆಗ್ತದೆ. If N21 is greater than 1, then ray bends towards the normal. Means ray is traveling from narrow medium to denser medium. If N21 is less than 1, then the ray, of course, refracted ray bends away from the normal. Hope you understand. When refracted ray, this N21 refractive index of second medium with first medium is less than 1, then your ray will bends away from the normal. This is I, this is R with respect to normal only. Then sin I by sin R, value of R will be greater. Sin R will be greater. Denominator is more. Denominator more it will be less than. N21 will be less than. Correct? Okay, this point you have to remember. Okay. Next point. These are some points to be remembered while studying refractive index. Refractive index study ಮಾಡಬೇಕಿದ್ರೆ ಈ ತರ ಪಾಯಿಂಟ್ಸ್ ಇರೋದೆಲ್ಲ ನಾವು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. That's all. Now, see, we can define refractive index in this way also. In which way? Definitely, refractive index of second medium with respect to first medium is also defined as, let me repeat, refractive index of second medium with respect to first medium is also defined as it's a ratio of velocity of light in first medium to velocity of light in second medium. Let me repeat. Refractive index of second medium with respect to first medium is also defined as velocity of light in first medium. It's a ratio of velocity of light in first medium to velocity of light in second medium. This also holds for this lambda1 divided by lambda, ratio of wavelengths in first medium and second medium. This equation is very important. We use this equation in chapter number 11. We'll use next chapter we use while deriving some equation related to refraction reflection. I will tell you that. I'll make a discussion on. Please remember we have this equation. What equation? The refractive index can be defined in terms of velocities also. Again, it's a ratio of velocity of light in first medium to the velocity of light in second medium. This is very important equation. Okay? Hope you understand. Last point regarding refractive index is absolute refractive index. Once again, absolute refractive index. What is the absolute refractive index? Absolute refractive index represented by n. Absolute refractive index is a ratio of light in vacuum. You know, velocity of light in vacuum is represented by c. This is the highest possible velocity, highest possible speed attainable in nature, or it's a limiting value of nature. Correct? You know? It is a ratio of velocity of light in air or vacuum to velocity of light in a given medium. Let me repeat. Absolute refractive index is defined as it is a ratio of velocity of light in vacuum or air given represented by c only. It is represented by c only. C to velocity of light in medium, given medium. It's called absolute refractive index. Please remember this. Please remember. Okay. Now, without wasting time, let's move to next concept. What? Consequences of refraction. The concept is consequences of refraction. Consequences of refraction. We have to study 2 to 3 consequences like mirage, lateral shift, normal shift. Let's study one by one. First, let us consider lateral shift. These are not very important from exam point of view. Anyway, we have to study this. Lateral shift. Okay. Let us consider a glass slab. A glass slab. I have using glass slab. We have in laboratory we have one glass slab, definitely number of glass slab we have, and one experiment related to glass slab. Fine. We observe a phenomenon called lateral shift when the ray of light is allowed to pass through a glass slab. See, A, B, C, D is glass slab. Here, when ray of light is allowed to fall on this glass slab obliquely, here we have 2 media. First one is air, second one is glass. Of course, no need to tell you now, air is rarer medium, glass is denser medium. A ray of light is traveling from rarer medium to denser medium. This is the first interface. At the first surface, first interface, first set of media. One is air and another is glass. Of course, we have discussed what? When ray of light incident on a refracting surface gets to from rarer to denser, then the ray of light will bend towards the normal. Normal bend. This is angle of incidence, say I1 for simplicity, angle of refraction, say R1. Now, here we have second interface. At a surface DC, here ray of light must travel from denser medium to rarer medium. Why? Now this is water. Sorry, this is glass. Correct? Denser medium. Let me draw some normal here. This is the direction of light. Okay? Visible, I hope. This is normal. This is normal. Now, as light is traveling from denser medium to rarer medium, we know it will move away from the normal. What? Refracted ray bends away from the normal. So, this is a normal. With respect to normal, we have to mention angle. This is the angle of incidence, say I2. This is the angle of refraction, say R2. We observe this I1 and R2 are parallel. Now, we observe this I1, this I1 and R2 are parallel. I1 and R2 are parallel. Or this ray and this ray. I mean ray, okay? This ray and this ray. This ray is called incident ray. This ray is called incident ray. This ray is called emergent ray. Let me repeat the sentence now. Incident ray and emergent ray are parallel. Incident ray and emergent ray or rays are parallel. But we observe some shift, some perpendicular shift, some lateral shift throughout the process. ಈ process ಅಲ್ಲಿ ನಾವು ಏನು observe ಮಾಡ್ತೇವೆ ಅಂದ್ರೆ there is some lateral shift. ಒಂದು lateral shift ಇದೆ. ಆ lateral shift ಅನ್ನು ಹೇಗೆ identify ಮಾಡೋದು? Let me extend this incident ray. Incident ray extend ಮಾಡ್ತೀವಿ. What I get? In the absence of this glass slab, this would be the path of incident ray. ಈ ಗ್ಲಾಸ್ ಲೈಟ್ ಹಿಂದೆ ಹೋಗಿದ್ರೆ ಬೆಳಕಿನ ಕಿರಣ ಈ ದಾರಿಯಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ. The path taken by incident ray in the absence of what? This glass slab. But due to presence of this glass slab, there is some lateral shift. This perpendicular distance, there is some perpendicular distance. This perpendicular distance is called lateral shift. This perpendicular distance is called lateral shift. What is lateral shift? Lateral shift is defined as it is perpendicular distance between emergent ray. Okay, so you can name it P2 R S T S T, emergent ray S T, and incident ray extended. Incident ray extended. Extended it is a perpendicular distance between emergent ray and incident ray extended. It is a perpendicular distance between emergent ray and incident ray extended is called lateral shift. Just remember it, right? Lateral shift has some formula, some equation like Ls is equal to T sin I minus R divided by cos R. This equation holds good where T is thickness of this glass. Okay, just remember you may use this equation while solving some of the problems. Okay, now last concept. I'm looking at the time. Last concept. After my class, Shaman's class is there, right? Okay. Last concept is normal shift. Normal shift. When we observe a tank filled with water, the bottom of tank seems to be raised. The bottom of tank is raised. This is due to phenomena called normal shift. What is normal shift then? It is an apparent shift, not actual, apparent. Apparent means in Kannada. In apparent means Kannada. What? Okay, I will think the Kannada. It is apparent shift in the position of object which is placed in one medium and viewed from other medium normally. Obliquely also it holds good, but it's in definition it is normally. What? Let me repeat. It is apparent shift in the position of object placed in one medium and observed from another medium. Apparent ಕನ್ನಡ ಶಬ್ದ ಬಹಳ ಚಂದ ಇದೆ, ನೆನಪಾಗ್ತಿಲ್ಲ ನಾವು. ತೋರಿಕೆ. ತೋರಿಕೆ ಒಂದು ವಸ್ತುವನ್ನ ಒಂದು ಮೀಡಿಯಂ ಅಲ್ಲಿ ಇಟ್ಟು ಮತ್ತೊಂದು ಮೀಡಿಯಂ ಇಂದ ನೋಡಿದ್ರೆ ಅದರಲ್ಲಿ ತೋರಿಕೆ ಶಿಫ್ಟ್ ಗೊತ್ತಾಗುತ್ತೆ. It seems to be, it's not actual, it seems to be raised up. This apparent shift is called, this apparent shift in the position of object is called normal shift. Okay? Now I will stop. 20 minutes late I will class correct due to some technical issues or something. Let me stop the class and I will continue tomorrow with drawing all these things. Thank you. Take care. Bye bye. Thank you.